Take 2 points on a circle and draw a line straight through. The space which was encircled is divided into 2. To these points add a third one, which gives us 2 more chords. The space through which these lines run has been fissured into 4. Continue with the 4th point and 3 more lines drawn straight. Now the count of disjoint regions sums in all to 8. A 5th point and its 4 lines support this pattern gleaned. Counting sections, one divines that there are now 16. This pattern here of doubling does seem a sturdy one, but one more step is troubling as the 6th gives 31. Wait, what? 1, 2, 4, 8, 16, 31? What's going on here? Why does the pattern start off as powers of 2, only to fall short by 1 at the 6th iteration? That seems arbitrary. Why not 1, 2, 4, 8, 16, 32, 63? Or 1, 2, 4, 8, 15? If you keep going, the number of sections deviates even further from powers of 2, except when it hits 256. But this just begs the question of what the pattern really is, and why it flirts with powers of 2. In my next few videos, I'll explain what's happening, which will include one of my all-time favorite proofs. But interesting problems deserve to be shared, pondered, and discussed before their secrets are hastily revealed. So while I work on animating my explanation, I encourage you to think of your own. To be clear, the question is this. If you take some set of points on a circle, and connect every pair of them with a line, how many pieces do these lines cut the circle into? Does it matter where these points are? And why does the answer coincide with powers of 2 for fewer than 6 points?